Hello students, today we are going to learn about a very interesting topic in the area of ecology called as Theory of Island Biogeography. Now, before I start with this concept, let's try to understand what this Theory of Island Biogeography denotes. Now, this island biogeography concept basically refers to the study of geographical distribution of species and the reason for such distribution pattern. You must have heard that a particular plant is more dominant or predominant in, let's say, the Himalaya, or a particular plant or animal is more dominant in the desert area. So that is called as the geographical distribution of species. And when we try to study the reason for such distribution pattern, then we are actually discussing about the theory of island biogeography. Originally, this concept was proposed by two scientists called as MacArthur and Wilson, who originally proposed this theory by the name of equilibrium theory of island biogeography. Now, let's discuss about this theory. The theory basically refers to that the number of species on any island is determined by a balance between the rate of immigration of species and the rate of extinction on that island. Basically, we will be discussing about this theory in a lot of detail. And what you have to understand that we will be referring to a word called as island, and that island can be a number of examples like oceanic island, habitat island, and mountain peaks. I will discuss about that. So one keyword or new word for you is the term island. And the theory says that on any island, the number of species at any point of time will be dependent upon what's the rate of immigration. That means how many species are migrating to that island. And what's the rate of extinction? That means how many species are getting extincted from that particular island population. Now, if I were to explain you about the word island, the term island in this theory can refer to either oceanic islands, it can either refer to habitat island on land, or it can even refer to mountain peaks. Now let's start with the original foundations of this theory by MacArthur and Wilson. The story starts with explanation around an empty island. So let's assume that an island few hundreds or several years ago, it was almost empty, right? Or nearly empty. Very few species shown by yellow dots. So when an island was almost empty, and at that particular time, the extinction rate is going to be extremely low. And what's the reason for that that you can think about? The reason for low extinction rate on an almost empty or an empty island is that only few species are available to become extinct, right? So there are only few species. They will not be competing with each other. The island is almost empty. Everything is in a favorable environment, right? Then no extinction will happen because of competition. And now, suddenly, let's say the number of species on that island start to increase. What's going to happen to the extinction rate? The extinction rate is going to become high, mainly because of competitive exclusion. So, when the number of species on islands start increasing, the resources will start to become limited in number, as a result of which competition will be triggered. And competition will always result in removal of the inferior or the competitively inferior species. Now, along with high extinction rate, one thing is going to happen, that is decrease in immigration rate. So when an island is already populated and competition is happening, fighting is happening for resources, new species from or new individual from other areas or islands will not prefer to move to this particular island. And as a result of which, you will have a decrease in immigration rate. So from an almost empty island to full island where the species are almost saturated, this is going to have a high extinction rate plus a decrease in rate of immigration from the new species. And ultimately, I would say that there are two opposing forces which are interacting on this island. One is the force of extinction. That means as the number of species increasing, the extinction rate is going to increase. And the other one is immigration. Now, two opposing forces are working out, and you can see these opposing forces will actually result in something called as equilibrium level of species richness. I repeat, they will result in equilibrium level of species richness. And what does actually this thing mean? If you look onto this graph, in this graph, the x-axis is number of species present, y-axis is the rate of change of number of species, and the red line is indicating the increase and extinction of species. So I told you, as number of species on island will increase, it will trigger an increase in the extinction rate because of competition. So in this particular figure, I have just represented an asterisk, right? So what does this asterisk, purple asterisk indicate? This indicates extremely high rate of immigration, right? So in this particular graph, the immigration rate was quite high during the initial days when the island was empty. So high rate of immigration were only occurring at the time point when the island was empty or almost empty. I hope that makes sense. Now, we are coming on to an important concept. That is, what are those physical features which can actually influence the equilibrium number of species? And those features are the island size and distance from the mainland, or distance of island from the mainland. So let's tackle the first important area called as the island size, right? The island size. What are the variation that we have in island size? Let's consider two extreme examples. Suppose there is a small island. Now, the small island will have high extinction rate. Can you think about the reason for that? The reason for that is because of the fewer resources, right? So, a small sized island will have extremely high extinction rate due to lack of resources. But there is one more reason. The second reason is lesser spreading area to avoid competition. When the island is small and the species are increasing, then obviously there will be a scarcity of resource. Plus, there is very less area available where the species can hide from each other to avoid competition. That is called as less spreading area to avoid competition, as a result of which a smaller island is going to have extremely high extinction rate. Coming on to the large island, let's suppose that there is an extremely large size island compared to a small island, it will have an lower extinction rate. Now, what is the reason for low extinction rate? The reason is that there are few chances of interaction between competing individuals. There are very less chances that individual will face each other, and therefore lesser competition and lesser extinction rate because of competitive exclusion. Now, for a moment, let us assume that the two islands are having similar rate of immigration. The small and large island, they have the similar rate of immigration. Now comes the important part. So if the x-axis of the graph represent number of species and the y-axis represent the rate of extinction, this first red line that I've drawn represents the extinction rate for small island, while the green line indicates the extinction rate for large island, right? As clearly visible from this particular point, the small island is having a higher rate of extinction compared to the large island, which is having a lower rate of extinction, right? I hope that makes sense. And if we were to suppose constant immigration rates or similar immigration rate, then these point of intersection will be representing the equilibrium number of species. And that will be the question for your CSIR examination. So there are two equilibrium number of species, one A, which is for small island, and the other one is B, which is for the large island. And the question for CSIR will be as follows. The equilibrium number of species will be higher for which island? It will be higher for the large island as shown by the graph also. It's a higher value of number of species compared to a small island. So if we assume that the rate of immigration is constant, then you are comparing the island size, and in that case, a large island will always have a larger equilibrium number of species compared to a smaller island. Now, this was about the effect of island size. Let's try to understand about the effect of distance from the mainland. Now, mainland is an area which is from where species migrate to a particular island. So the distance of an island from mainland is going to be another important crucial factor. So let's try to understand about that. So let's assume that we have one criteria called as far island. Now, far island means that from the mainland, this island is miles and miles and kilometers away, right? So a far island is going to have a smaller rate of immigration. What is the reason for that? Smaller rate of immigration because it's difficult for species to migrate to such large distance. They won't prefer migrating such huge distances. So a far island is going to have a smaller rate of immigration. Now, what would happen if this was an island near to the mainland? So for a near island, the rate of immigration will be extremely high because everybody prefers moving to this near island from the mainland, right? Now let's have a look at the graph. So for a moment, let's assume that we have similar size of the island and the extinction rate is also identical for the two islands. Then in that case, the x-axis representing number of species and the y-axis representing rate of immigration. The green line represents the rate of immigration for near island and purple is for far island. And as I just discussed that the near island will have a higher rate of immigration compared to a far island which will have a lower rate of immigration, right? I hope that makes sense to everybody. So we have this particular point, and now moving ahead, that if we assume that we have similar rates of extinction, then we will once again have points of cross section, and those point of intersection or cross section will be the equilibrium number of species. And interestingly, the equilibrium number of species will be higher for the near island compared to a far island. I hope that doesn't cause any problem till here, right? I will be concluding the statement now. So in conclusion, what we are saying is that if the of comparison is size of an island, then a small island and a large island, if you are comparing them, then a large island will always have higher equilibrium number of species compared to a small island, assuming that immigration rate is identical or constant for both of them. If we assume similar size and rate of extinction and you are comparing the distance from the mainland, then the near island will have a higher rate of uh, will have a higher rate of or will have a higher equilibrium number of species compared to the far island. So in conclusion, we can say that the equilibrium number of species will always be higher for a large island near to the mainland compared to a small island which is far away from the mainland. And this has been one of the favorite questions every year in Part C CSIR. Thank you and have a nice day. I will be returning back with an amazing video soon. Thank you so much.